All right, looking at another example, we have x of t is equal to 2 to the et, and y of t equals 1 plus e to the t for t greater than or equal to 0. So we want to graph this and make sure that we remember to include the direction. And it's going to be a little bit of a nasty problem because given e, I'm going to be rounding my answers just so I can get some form of points on there. And I usually try not to adjust my scale, but I think because of the nature of how both of these are going to be growing, that we may have to. So let's look at making a table. We have t x, and I'll probably need some more space here. So t, x, and y. So let's go ahead and try 0, 2, 4, and 6. When we plug in 0 for x, for t and x, we'll have 2e to the 0, which is just going to give us 2. When we plug in 2, it's going to be 2e to the 2. And when I punched that into my calculator, I got approximately 15. And so when we plug in 4, it'll be 2e to the 4, which I got is 109. And when I plugged in 6, it's 2e to the 6, in which I got approximately 807. Alright, so these are really big. Let's see what's happening over here. When we plug in 0 for t and y, it's going to be 1 plus e to the 0, or 1 plus 1, 2. And then 1 plus e to the 2. And let's just say approximately 8. And 1 plus e to the 4, that's approximately 56. And 1 plus e to the 6 was approximately 404. So in this instance, whoa, this is a pain in the butt to graph. I know I can still do this one. I'm going to start here. And I know for a fact that whatever this thing is doing, it's going to be in that direction. But I might want to like play the cards, right? I don't really want to extend my scale. What if I try to write this as the rectangular equation? So when you do this, you want to look at the equations both for x and y, and ask yourself, which equation can I solve for t more easily? And they're both equally the same. So in the last problem, I solved for t and x. Let's just solve for t and y. So y of t equals 1 plus t. It means that I'll have y equals 1 plus e to the t. I'll go ahead and subtract 1 to both sides. Then I can natural log both sides. And then when I natural log the right side, it's just going to be left with t. So now I have an equation for t for y. Let's plug that in for x. So now I'm going to have 2e to the ln y minus 1. And this is kind of the cool part about all the things that we're learning, is just like that. We have to apply the properties of logs that we've learned. And so if you have e to the ln base e of y minus 1, that's going to simplify to 2 parentheses y minus 1. And so really, we just have another linear equation. It's just given to us in y in terms of x. So essentially, the rectangular equation is 2y minus 2. And so playing with this, so if like y is, well, we can always actually go ahead and solve for y, so we can just graph this a lot faster, right? So if we solve for y, adding 2, divide by 2, so y would equal 1/2 x plus 2. And so we know that we're going to have to start at x equals 2. No, because then that looks a little fishy. Because when x is 2, you get 3. Oh, I know what I did wrong. This is not supposed to be 2. When you divide both sides by 2, this will be 1. It's not letting me erase, so I'm just going to scratch it out. And so now when x is 2, I'll still get 2. When x is, now we know that it has a slope of 1/2, so just keep going using your slope. So up 1 over 2, up 1 over 2, and it's going to keep going in this direction forever. And it's going to be important that you include the arrow going on, because t is still going on, so those order pairs of x and y are still going on. And so we can say that for either of these, x would have to be greater than or equal to 2, or y would be greater than or equal to 2. And that's how you would do this problem. This was too scary for me. So you have some different ways to manipulate these to get to the answer. Ideally, you still want to see which direction it's headed, so it was necessary to do this. Alright, I'll see you in another video.